Hello everyone. Today we are going to build uh, one of the best and simplest classification model called K nearest neighbor. So before we get into the coding part, let's explore the math behind it, and there's some interesting thing about KNN too. So I hope you guys can see me. I'm right here. So let's get going. Okay. K nearest neighbor is very different from some of the algorithms that we know in machine learning. Usually, machine learning algorithm learns by updating the weights, but K nearest neighbor works entirely different. So let me give you a quick demonstration of how KNN works. Let's assume like this is a two-dimensional space. So imagine you have two classes. One is blue, here we try blue, and another one is yellow. Okay. So the task that we have is when we have a data point, we need to classify the data point based on the similarity to the classes that we already have. We just have to classify whether the newly introduced data is on the yellow side or on the blue side. So to find that, what we are doing in K nearest neighbor is we find the distance between each point and the newly introduced data point. We find the distance between all these points, all this point. Okay. Am I audible? There's something wrong with my headset. Okay. I believe you guys can hear me. So the next thing that we do is we after we find the distances, we sort this based on the distance from in ascending order. So let's say we have some points blue, blue, yellow, 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 and blue. So I have earlier written some of the lines. This this is the smallest line, the most largest. Okay, based on their distance, we kind of sort it in this way. So the next thing that we need to do is to give a parameter called k, which will be helpful in our k nearest neighbor. Why? That's why it's called k nearest neighbor. So we have, let's give it a value of, let's say, 6. So when we give the value k, the I mean when we give 6 to k, what we are actually doing is taking top k result of this, and the next step is we find the most common class, or which class is more present in this area. And in our case, the yellow, in our case the yellow have uh, like 4 representatives, and the blue only have 2 representatives. So the most likely chance uh, of the newly introduced data can be in is in this class. So that's how we classify using k-nearest neighbor. To find the distance between these data points, we have an equation called Euclidean distance. Euclidean distance. It's nothing but it's the square root of the summation of summation of point 1 and point 2 the whole square. So this equation is the foundation of k-nearest neighbor. So let's get into the coding part. So I have already imported the scikit-learn libraries and everything, and I configured some small data set to train our KNN model, and I also splitted the data here. This is nothing but the basic configuration that we does in machine learning. We just get the data and split it into training and testing part. So the first thing, to create a k-nearest neighbor, let's create a class called KNN. Okay, we need to initialize with self k. So this is the key part. This is where we give the k and self dot k to k. Okay, now we need to find the Euclidean distance, right? Euclidean distance. So it will have two value, x1 and x2. So this two value will be an array. This will be an array, and this will also be an array. So let's go to the equation. Square root sum squares. So np, we imported numpy, np dot sum, no, np dot square root, np dot sum of x1 minus x2 whole square. We gotta return that. Okay, I believe you guys can see this. I'm not sure, like, this is visible to you. Settings. Where is the zoom feature? I'm not sure. Let me check that out for a minute. I'm sorry, guys. It took me a while to figure out how to zoom this entire code. This is Jupyter Lab, so we cannot just do the control plus thing. So after the Euclidean distance, what we are going to do is we're going to fit our data. So self x train, y train is going to be there. So what we're going to do is, when we are fitting the data, it's nothing but we're just saving the data there. Okay, here's a self dot x train equals x train and self dot y train equals y train. Yeah, it's done. Now next thing that we need to do is to predict the data, right? We have self and x test, right? So what we are doing is we are taking every value from the x test, then we are passing it through a function, a function that we are going to write, which is called predict self, and it's going to take a value called x. Let's give us, So what we're going to do is our prediction will be this. It's the value pass uh, self dot predict of uh, let's say x for x and x test. Okay, we're going to return the prediction. The prediction. Okay. Now what we're going to do is we are taking each data point and we are going to find the Euclidean distance of it, and we are going to sort it based on the distance, and we are going to take the most common value, and we are going to uh, take that as an output for the prediction. So let's get to that part. We are finding distances. Distances is equal to self dot Euclidean of the x will be same, and we're taking it based on the training data. Okay, this is a bit kind of an algorithm that it doesn't work like in usual machine learning algorithms, but uh, you have to have some patience to understand this. So we're going to take is self dot x train. Okay, sorry, each element of x train I for I n self dot x train, right? So what we're going to do is we're going to clip this array with the k. This is going to be after sorting we're going to do that. So sorted distance is going to be np dot arg sort distances, and we're going to select this by self dot k. Okay, so the next thing that we're going to do is after we got selected the sorted array, now we're going to take the let's say take with that index we're going to take the most common in the training most common class in the training set. Okay, so like selected is going to be the most common thing, which is self dot white train of I for I in sorted distance. Okay, now we're going to do is we are returning most common okay import this function called counter. We can use to find the most common class. We can also use hash map or any other method that you want. I'm using this for convenience. Counter of selected most common. Okay, most common one. Let's give name counter. Counter. Oh, it should be imported from collections import counter. Okay. We got a KNN, which is KNN. Let's give the value 54 now. KNN dot fit x train try train. Okay, KNN dot predict x test. Hmm. What happened here? There's something wrong with our data set, I believe. Is that because it's a string? I think there's a string value in our data. It should be because it's from scikit-learn data sets, right? It shouldn't be empty. Like I tried many times, but there shouldn't be any string data or an empty value in scikit-learn data set. Hmm. Okay, I think like I already looked at the data types. Uh, I think since we're like since we're basically using the numerical value, right? So I think the columns is causing the error. So let's like iris dot data iris dot target. Let's give it. Voila. Oh, I think works fine. Let's use indexing. Okay, we going. I'm just like taking based on the indexes. So here, like we predicted our data. Let's test the report, right? Y red predicted Kenya's neighbor like classification report. True value first. Y test. Y prediction. Let's print this. Okay, we got really good score. That's unexpected, by the way. So you can play with the K part. You can just play around with it, and if you want, you can do hyperparameter tuning to create the best model. So the one thing that most of the people makes mistakes in machine learning is this is a thing that is not related to this, but commonly in machine learning is people are more focused on models than the data. A model without a good data is useless, and uh, good data with worse model is also uh, not good. So when you're trying to make machine learning models, always try to make the model and the data more perfect. If we have a bad data, no matter how good you make the model, it's not going to work as good as we want. So this is how we make k-nearest neighbor. So I will be back with amazing tutorials which explains like how to build decision trees from scratch, random forest from scratch. Till then, bye.